Hey, if you'd like to earn CEUs for this webinar, join the Safeopedia community at the link in the description below. Now, on to the show.
First of all, thanks for the opportunity. I'm with Moldex. Those of you who don't know who Moldex is, we are a privately held US-based manufacturer of respiratory protection products, hearing protection products, and very soon in New Orleans, we're going to launch a line of niche eyewear. So I've been asked today to talk about respirators, not really the product, but the basics of respiratory. Which is kind of broken down into three parts. The first one is, why do we need respirators? Why are they used? And then also some regulatory requirements, because this is a regulated industry. We have two agencies that are intimately involved, sometimes too much, in respirators. One of them is called NIOSH. And National Institute for Occupational Safety and Health. All government agencies have acronyms, so hang in there. And then you have OSHA, which is really governs the health and safety of the workplace. And both of these work in tandem with respiratory. So in order for a respirator to be sold in the United States and frankly, also Canada, it has to have NIOSH approval. And that means it's tested by NIOSH and approved by NIOSH that it'll do what it's supposed to do. If it doesn't, then it's not a respirator. So one of the experiences we had during COVID was we had a lot of product coming in the United States that either purported to be NIOSH approved, or we had KN95s from China. Just be advised that if you're going to go into a mandatory respiratory program in the United States or Canada, it has to have NIOSH approval or CSA or both. So those are sort of the agencies that you're going to be dealing with. And OSHA comes behind and says, here's how to do it, and here's what we expect if you're in a mandatory respiratory program. So there's a PowerPoint presentation being presented, I think. And I hate PowerPoints from the standpoint, I'm not going to read from here. So I assume all of you can read, or at least look at pictures. There are a bunch of requirements. There are 10 of them, actually, that OSHA requires. I'm not going to go through all these. Suffice to say that the OSHA website has plenty of resources. Moldex has resources, and most of the major manufacturers have resources to tell you what to do. Probably of this list, the ones that stand out to me that are the ones that are the heavy lifting is probably number 2, developing a procedure for selecting respirators, 4, fit testing, all kinds of controversy over that most of the time. And then probably 7 or 6, no, 7, trying to determine the adequate air quality in a facility. So what we're going to do first is talk a little bit about the importance of respirators. Because listen, let me just say, you don't need to do the OSHA steps if you don't have a respiratory program. If you're thinking about having a mandatory respiratory program, or you think you need a respiratory program, then we'll get to that point. But first, I want to go through the importance of respirators, because I think sometimes people don't understand what respirators always do. So there's all kinds of different hazards out there. And they're sort of broken down into these elements. So it's kind of like earth, wind, and fire. Solids, liquids, gases, mist, dust, and fumes. Yay. All right, so an example of a fume is when you're at a gas station and you're pumping your own gas because nobody pumps gas for you anymore, and you smell the gasoline. You go, oh, I smell the gasoline. It's a fume, but it's not necessarily dangerous. It's just that some people actually like the smell. But these are the hazards we're dealing with. So basically what happens is a respirator is a barrier between the hazard and your respiratory system. It could be a particulate or a particle. It could be an aerosol. It could be an actual chemical. So the selection of respirators is going to be determined by what you have in your workplace, right? What hazards? So the first thing you need to do is evaluate. Actually, anticipate is one of the first things you need to do. And anticipate means, hey, look, I'm going to look at my procedures, my processes, what we do in our facility. And if I'm going to set up a new process or department or procedure, what do I need to do to anticipate using respirators? It's actually the anticipation is, what's the air quality going to be? All right. So then you need to recognize the hazard. And you can do that in one of three ways, at least one of three ways. One is MSDS sheet from the chemical manufacturer or from the manufacturer of whatever product or machine you're using, whatever the output's going to be. Number two, the SDS, which is sort of the new version of an MSDS, or air sampling. Now, air sampling is something that a hygienist needs to do. If your company does not have one on payroll or available, there are lots of third-party hygienists out there. Many of the distributors that are associated with this group may have resources that you can use. Bottom line is, it's as an employer, it's your responsibility to recognize the hazard. Once you've recognized the hazard, you have to evaluate the hazard. Evaluating the hazard is really about how many parts per million, what's the extent of the hazard, how dangerous is it? Is it above the permissible exposure level, which we'll get into in a minute. Bottom line is, you're trying to determine if you're going to put people in this workplace, what are they walking into and how can you mitigate that particular hazard? So controlling the hazard is the next step. And controlling the hazard means, how do I minimize the hazard, or how do I eliminate it? The first thing any company should do is eliminate the hazard with engineering controls, or you can substitute less toxic substances. So that's really determined by your air sampling or what the MSDS or SDS sheet says. And then from there, you can determine what you're putting your workers, what the area where the hazard exists, what kind of output or what kind of air quality there is. Okay. So once you've done that, evaluating the hazard is a function of, like I'm standing in a room, in a conference room right now, and the air quality is fine. I've got plenty of oxygen. There's particulates floating around. I'm sure I can't see them, but they're not dangerous to me. Okay. If all of a sudden we filled this room full of dust or some sort of chemical, it could very quickly turn into a hazardous area for me to breathe. So it's really about measuring the air quality. And there's something called a PEL, permissible exposure level. So consider that a line in the sand. Above that line, danger, danger, okay? Below that line, you're fine. And that's the gasoline example I gave is a good example. You're outside, you're pumping gas, you smell the fumes. It may be irritating to you. You don't like to smell the fumes, but it's not dangerous. There's plenty of air. The parts per million of that fume are acceptable. However, in a closed environment or in an environment like a construction site where there's lots of dust and maybe silica, it could be very dangerous. So when you monitor the air, you're looking for how many parts per million of that particular hazard or that particular chemical or particulate. Then you compare that to the permissible exposure level for that particular hazard or dust particle. And how do you get those? Where do you get those? Well, OSHA and NIOSH have tables that you can use. And at the end of this PowerPoint, which you'll all get, I hope, there are links to those types of tables. But also every major manufacturer in the United States, I emphasize major, somebody that's been in the business for a while, knows what they're doing, has a chemical selection guide. And in those chemical selection guides, you'll find PELs for each of the hazards. So permissible exposure level simply says anything above this, you have to reduce the exposure below the PEL. And how do you do that? Well, you can engineer the hazard out. You can use less toxic substances, or you can use respirator. Okay, so the respirator is going to filter that out so that the breathing air, the breathable air is acceptable, all right, and the worker's safe. All right, then all the manufacturers that make respiratory equipment have something called an APF, another acronym. Write these down, these are important. Alphabet soup. Assigned protection factor. The hell does that mean? That means that a half mask respirator gives you 10 times, is designed when properly fitted, properly functioning, and trained, the user's trained. You know, those bold-faced words on this PowerPoint, I think they're on the PowerPoint, I think. Okay, that's really important because if it's improperly fitted, improperly trained, or improperly into that, it's worthless. You don't put a respirator on someone and not make it fit properly. That's crazy. That's silly. That's lazy. All right. But you're not going to get the result you want. So half mask has an APF, an assigned protection factor of 10. So if the PEL is 1, you can go all the way up to 10 with the respirator. Okay. Full face is a little different. It's a little, if you're doing one type of fit testing, it's 10. If you're doing another type of fit testing, it's 50. You're not going to get into all the details of that. Suffice to say that respirators in the United States, or at least the respirators from major manufacturers, are designed to have a safety factor built in so that when you put somebody in an area and you know that the hazard concentration is above the PEL, you know the respirator is doing its job. Again, when it's properly functioning, properly trained, and properly fitted. Okay, really important. Okay, then there's maximum use concentration, which is really the top end, PEL times APF. I'm not real good at math or calculus, but I think that means that you can't go higher than a certain level. Okay, so those are sort of the basics. Now, let's talk about the types of respirators just for a couple minutes. There's half mask and full face. So half mask, whether it's a disposable or a reusable elastomeric, a half mask covers from the bridge of your nose to the bottom of your chin. Why? You breathe through your nose and your mouth, right? You don't breathe through your ears. Okay. Some people talk from other parts of their body, but basically it's your mouth and your nose. Okay. Full face goes from the top of your forehead to the bottom of your chin. Now, full face will provide, at most times, will provide primary eye protection. So if you're in a chemical like ammonia, for example, that can permeate into your eyes and really cause issues, you might need a full face, or you may have to wear a pair of safety goggles or something like that. That's up to you, the employer, to evaluate the hazard. So you've got half mask and full face. All right, you've got disposable respirators, and you've got reusable respirators. All right, so Moldex only makes negative pressure respirators. Okay, what's negative pressure? Negative pressure for me is the sales aren't high enough and I need to get my sales team. That's negative pressure. Somebody comes in and yells at me for not getting sales up. But no, negative pressure is you're the engine. So when I breathe in and I breathe out, I'm forcing air. I'm taking air in through the filter and I'm breathing it out through the filter. Negative pressure. There's negative pressure around my face. Now I have a beard, so I can't wear a tight-fitting negative pressure respirator. Okay. I was told that growing a beard would make me look better and more distinguished. I was misled. So there's also something called powered pressure APRs, which you're taking either a belt pack or some motor, and you're pushing air through a filter so that it's filtered into your mask. The PAPR is common, where you either have a tight-fitting PAPR or a loose-fitting PAPR. And what happens is you're wearing this, and the belt pack runs a little fan, and the fan sucks air in, pushes it through a filter into your mask, so you're breathing that filtered air. You also can have SCBAs, self-contained breathing apparatus. The best example of that is firefighters that have a backpack, an SCBA on their back, They don't know what they're getting into. They have no time to evaluate the hazard other than it's fire and smoke. They don't know what's in the smoke. So they have a self-contained, the air inside those tanks, similar to scuba diving, is high quality air that's breathable. So they're breathing an air source, not from the environment, but from the backpack. And then there's supplied air respirators, which means you're bringing clean air, filtered air, good air in from a foreign source. So picture somebody wearing a full face mask in an environment with an air hose that runs outside. So they're breathing air from the outside. They're not breathing air in the particular environment. The selection of these respirators is determined by the hazard and the employer's risk aversion strategy. Okay. So sometimes they may decide that they need a positive pressure APR. For example, I wear a beard. So if I'm going to wear a respirator, I have a loose fitting mask that fits around my face and my beard so I can breathe in clean air. Okay. I'd ask if it makes sense, but nobody's going to answer me anything. All right, then. So great. We've got these half mask respirators and we've got these full face respirators. But what's missing? Well, you got to have a filter or a cartridge, right? Otherwise, you don't have a something that will filter the air. So a particulate respirator can look like this. You can have an N95 on this side. All right. This is a disposable respirator. This is a particulate P100 filter that goes on elastomeric. The bottom line is these filters are for particulates. Okay. Could be a solid or a liquid aerosol, dust, mist, or fumes. Let me give you an example of an aerosol particulate. COVID. The virus that we defined as COVID that put our country and world through hell over the last 2 years ago. At first, we were all washing our hands and doing all kinds of sanitary things that grandma used to tell you to do. And then we found out it was an aerosol. That means it was spread through particulates like a sneeze or a cough or breathing or some sort of exhalation. And in those particulates was the virus wrapped around some sort of liquid. And then when we found that out, all of a sudden N95s, because they would trap those particulates, were a way to help you prevent getting COVID. It won't ever prevent you from getting COVID, but it'll help. And that was something we learned during COVID. So that was a particulate that was used. Chemical cartridges that look like this, okay, they have activated carbon in here, and that carbon absorbs the chemical such that it reduces it to a below the PEL, so that you're not breathing something you shouldn't be breathing. Chemical cartridges, a particulate filter, to take it out of service when it's hard to breathe through, because it traps particulates. It's trapping them, trapping them, trapping. And finally, all those trapped particles make it hard to breathe through. So it becomes hard to breathe through, you take it out of service. All right. Chemical cartridges are a little trickier. They have a service life or breakthrough time. And that breakthrough time has to be determined by the employer. Now, we can help you with that, but it's determined by the environment. You have to have a change out schedule. So what a lot of companies will do is they'll determine their change out schedule and they'll mark a date for each employee. Each employee will mark a date on there when they're supposed to throw this out, okay? To prevent breakthrough. Breakthrough is not a good thing. You don't want breakthrough, right? So that's a chemical cartridge, and they're color coded. And they're color coded to determine what the use is, what the particular filter or chemical it protects against. Okay. I'll get to this in a second, but every one of these is standard to the industry. Moldex doesn't get to use yellow, and somebody else gets to use green. Everybody uses yellow for the same hazard. In terms of filters, going a little bit backwards, you're probably all familiar with N95, okay, N95 and N95, okay. But these are the filter efficiencies. So there's types of particulate filters. There's an N series, an R series, and a P series. I was going to do NPR, but that sounds like public radio and nobody listens to it anymore anyway, so we'll just move right ahead. So N series is protection against any kind of non-oil, aerosol, particulate, all right, non-oil. So in your hazard evaluation, is there oil in there? Don't know. If you don't know, move up to an R or P. R is protection against oil or non-oil up to an 8-hour period, and then P series is a HEPA filter. It's a protection against oil or non-oil. So you can go down, but you can't go up. You can't be using evaluate, you need a P and then use an N. That's no. But you can go from an N to a P. Okay. You're getting a higher level of protection in terms of filtering efficiency and also oil protection. If you're not sure, that's where you go to the chemical selection guide. That's where you go to the MSDS. That's where you go to the SDS or the industrial hygienist who's done your evaluation. Make sense? Everybody's nodding their head, virtually nodding their head. Okay. So here, I just want to bring this up real quick. This is just basically the color coding for the chemical cartridges. Okay, now, so you've gone through all these types of, you've gone through your evaluation, all right? You know what you need, you think you know what you need, all right? You haven't selected your respirator yet, but you're getting there, you're close. Now you got to determine, based on your air quality, you're determining, I'm going to do a mandatory respiratory program. I'm going to require my employee, when they walk into this room or this environment, they must be wearing this respirator, this type of respirator, okay? Once you've determined that, now you got to go back to the OSHA 10 steps. And now you can start documenting and writing up the program, and you can start with training, you can evaluating, determining what respirator you want, how to train the employee, but you got to do fit testing. And there's two types of fit testing. There's quantitative and qualitative. Quantitative is using a port account or some similar computer-generated, software-generated. You can't lie to it. It measures the amount of leakage from your mask in an environment, and they determine whether you pass. Is it fitting tight enough? Is it doing its thing? Is it fitted properly? If it's fitted properly, you get a thumbs up. If it's not fitted properly, you get a thumbs down, and you have to either refit, meaning move it around, tighten it up, or select a different size, something like that. Qualitative is me asking you a bunch of questions while you're wearing a respirator, and I'm going to use some sort of inert chemical like bitter, which is nasty stuff if you get it on your fingers and you breathe it or you taste it. It's ugly. Not dangerous, but the idea is that when you're wearing a respirator, if you have too much leakage, what's the point, right? You're breathing in you're not reducing the amount or the air below the PPL. So there's no point in wearing. You might as well just not wear one if it's improperly fitted. So fit testing really determines there's a fit properly. Okay. OSHA requires you to fit test all respirators if you're requiring the employee to wear a respirator. That's mandatory respiratory program. And let me just clue everybody in. Maybe this is a respirator. This is a half mask respirator. In a mandatory respiratory program, you must fit test disposable respirators. So there's a lot of bad information out there about disposable respirators. I don't know what the fit testing. Yeah, you do. If it's a mandatory respiratory program. But there's always a loophole, isn't there, in federal government mandates? Under Appendix D in the OSHA standard, if it's a voluntary program, meaning, hey boss, I'm working and there's a lot of dust here, and I just or I smell the welding fumes, and I don't like it. I don't like it. The employer can turn and say, I understand your concern. However, we've done air quality, and I can assure you the air quality in this particular facility is acceptable. You don't need to wear a respirator. However, because we care about you as an employee, I'm going to give you this respirator to wear. Okay. Now, Moldex would like you to fit test that person because why wear a respirator? What's the point? But OSHA, if you have that employee sign Appendix D, meaning I acknowledge the company has done all this, and it's basically a waiver, then you can give them a respirator voluntarily. I do want to cover a couple things real quick to sort of summarize. So the first thing is that's really important is every manufacturer with every respirator gives you instructions on how to properly fit it, how to wear it, how to clean it, what it's used for, what it's not used for, etc. I can't stress the importance of that enough. And if you're not sure if a respirator is NIOSH approved, there are two ways you can find that out. You can go to the NIOSH website, and every respirator that's approved in the United States is listed, including those that are imported from other countries. But also on every box, there's a NIOSH box that shows the TC number, that shows it's approved. So if you have any question about whether it's a respirator or not, and it's NIOSH approved, it's easy to find. Obviously, if you can't find either one of those and you're confused, call our tech services department, we'll help you. We have a whole line of respiratory hearing protection and soon to be eyewear, and we focus on solutions for the worker. Okay, so happy workers, more productive workers, safer workers.